All right, let's talk about enterprise AI. There's one decision, just one, that can make the difference between a billion-dollar asset and a complete financial disaster. And that decision? It's your technology stack. Today, we're diving into the big clash, the fast, flexible world of Python versus the structured, secure ecosystem of C# and .NET. And trust me, this is way more than just code. It's strategy. And if you want to know why this choice is so incredibly critical, you just have to follow the money. By 2025, companies around the world are projected to spend a mind-blowing $1.5 trillion on AI. I mean, at that scale, we're not just funding a few cool experiments anymore. No, we are rebuilding the entire foundation of how business gets done.
But here's the thing. Here is the trap that is absolutely sinking budgets. Most companies are laser-focused on the tip of the iceberg, right? That first 15%. You spend getting a cool prototype up and running, but the real danger, the other 85%, is hiding right below the surface. We're talking about the massive, hidden costs of maintenance, infrastructure, and all the support that comes after.
So, let's go there. Let's dissect that hidden 85%. What in the world are these costs that can turn a super promising AI project into a financial black hole?
Well, they multiply, and they multiply fast. We're talking up to $2 million a year, just for infrastructure. And data engineering, the never-ending job of cleaning and prepping data, that alone can eat up 40% of your entire project spend. This proves a really critical point. The AI model itself, that's just the starting line. The real expensive work is everything you have to build around it to keep it alive. And this brings us to one of the biggest strategic pitfalls I see, the prototyping trap. It's a tricky one, because the very same tools and languages that let you whip up a demo over a weekend, they can end up creating massive, long-term technical and financial debt when you try to actually scale them for real enterprise.
And at the very heart of this trap, you find two completely different ways of thinking about programming. So on one side, you've got Python's dynamic typing. It's incredibly flexible, it's super fast, and that makes it an absolute powerhouse for experimenting. But on the other side, you have C# static typing, which forces you to build structure and be deliberate from day one. Now, for a big company, that required structure, it acts like a safety net, It's designed to stop those costly failures long after the project has gone live.
And the financial impact of that choice? It's enormous. Because C#'s compiler is designed to catch whole categories of errors before the code even gets deployed, companies can see up to 30% less in maintenance costs over the project's life. That little bit of structure up front literally pays for itself by preventing a fortune in fixes down the road.
Okay, so let's look at the actual frameworks. First up, you've got LangChain, the undisputed powerhouse of the Python world. You can think of it like a Swiss Army knife for AI development. It is unbelievably flexible, it's got a huge community, and there's a tool for pretty much anything you can dream of. It is the champion of getting a prototype built fast. And then its counterpart over in the .NET world is Microsoft's Semantic Kernel. Now, if LangChain is that Swiss Army knife, then Semantic Kernel is the enterprise architect's blueprint. It wasn't built for quick and dirty experiments. No, it was designed from the ground up for stability, for security, and for predictability inside a real corporate environment. So how does this C# and Semantic Kernel stack actually create a blueprint for AI that doesn't just work for a demo, but actually lasts? Let's break it down. So, what is Semantic Kernel, really? Well, think of it as a highly structured piece of middleware. It sits right between your complicated business apps and those powerful AI models, and it acts like a translator. It makes sure they talk to each other safely and predictably using these reusable little components called plugins. It basically turns unpredictable AI into a reliable, testable part of your software. Now, the magic behind all this predictability is something called the planner. So when a user asks for something complex like, hey, summarize my top 5 emails and then schedule a meeting, the planner doesn't just guess. It creates an explicit, step-by-step plan using only the tools you've approved. And that means the AI's behavior is auditable and totally reliable every single time.
And this whole approach, it becomes an absolute game changer for any company that's already invested in the Microsoft ecosystem. Why? Well, because it lines up perfectly with the infrastructure, the security, and the data policies you already have.
Let's talk about the #1 security risk in AI development today. I'm talking about leaked API keys. You know how it goes. You build a quick prototype, somebody on the team accidentally commits a secret key to a public code repository, and suddenly,
bad guys are racking up massive bills on your account. So how do you solve that?
The real enterprise solution is to get rid of static keys completely. Instead of a password that can be stolen, Semantic Kernel uses Microsoft's identity platform, Entra ID. This gives the AI application its own secure, managed identity. Access is then granted based on that identity's role, making sure the application can only do what it's explicitly allowed to do and absolutely nothing more.
And this secure connection, it unlocks your most valuable asset, your data. An agent built with Semantic Kernel can safely go read your company's SharePoint, it can summarize emails from Outlook, or it can schedule meetings in Teams, and it does all of this through the official Microsoft Graph API, which is basically the central nervous system for all your Microsoft 365 data. This turns all your internal information into a powerful and, more importantly, a secure tool for your AI.
And what's really important here is that this strategy is designed to be future-proof. You see, Microsoft is merging the rock-solid stability of Semantic Kernel with the experimental power of its multi-agent framework, AutoGen. And by 2026, the plan is to unify them into a single platform called the Microsoft Agent Framework. This makes sure that any investments you make today will carry forward into the future.
So, as we start to bring this all together, it becomes really clear that choosing between Python and C#, it's not just some technical preference for your developers, it's a fundamental business decision about what your long-term AI strategy is going to be.
The business case for the C# and .NET stack really boils down to these three pillars. 1, you get a lower total cost of ownership because of reduced maintenance. 2, you get enhanced, enterprise-grade security baked in right from the start. And 3, you get perfect alignment with the Microsoft infrastructure you probably already own and trust.
So what should you do next? Well, here are a few ideas. First, audit your existing AI prototypes. Are they secretly creating a mountain of technical debt? Second, take a hard look at your infrastructure. How much could you really save by using a native framework? And finally, talk to experts who actually specialize in building production-grade enterprise AI systems.
But ultimately, the whole choice really comes down to this one question. Are you building an AI for a flashy demo? Or are you building an intelligent system that will securely and reliably drive your business for the next decade? The answer to that question is going to define your success in the age of AI. Thanks for joining me.